Okay, we're going to look at the last geometry question of the November 20 Paper 2 exam. And here it is. It says, and you read this carefully, in the diagram, a circle passes through D, B, and E. There's a diameter. That's important. DE is the diameter of the circle produced to C and AC. AC is tangent. This line here, AC is tangent to the circle right at the point B. M is a point on DE such that AM is perpendicular to DE. That means it's 90 degrees. M2, there's 90 degrees right there. AM and chord BE bisect at F. So AM and chord BE, AM and chord BE intersect at F. I said we'd use word bisect, but it just says they intersect there. There we go. Okay, that's fine. Now we go. Let's just try it. We're going to prove that FBDM is a cyclic quadrilateral. You know, I actually go from F to B to D to M, make a little red thing on it when they give you a diagram to work with. So there, I'm looking at that right there. Now, they said that the diameter is ED. This triangle opens up to it, and I know that it is 90 degrees. That triangle is 90 degrees because it's an angle on a semicircle, on a diameter. So that's true. Okay, now we can say now that this has to be a cyclic quad because FBDM is a cyclic quad because this exterior angle is given. M2 is equal to 90 degrees, which is what we just figured out. And those are exterior angles. When the exterior angles are equal, it means that there must be a circle that goes around M, D, B, and F. So that proves that it's a cyclic quad. Let's prove that. Let's take a look and see if BF equals F1. We're going to try and prove that. Okay, well, we've got that BF here. Where are we here? B3. B3 is equal to F1. Well, let's take a look at this. We know that B3 is equal to D2 because this is an angle between a tangent and a chord. There's the chord. An angle between the tangent and the chord equals the equal opposite angle, that D2 there. So B3 is equal to D2. That's the tan chord theorem. And we know that F1 is equal to D2. F1 is equal to D2 because that's the exterior angle, and we just proved that it's a cyclic quad fits around these four things. Well, if that's true, if B3 equals D2 and F1 equals D2, then therefore B3 must equal F. And that's that question done. We just proved that B3 equals actually F1 right there, F1. Okay. Now the last question, we're supposed to prove that the triangle, the little triangle CDB equals the big green triangle CBE, way out there. Okay, that's not too hard because we've got one that C is common. C is an angle that both the little triangle and the big triangle share, CBE share. Now, but we know that B1 is equal to angle E because that's an angle between a tangent and a chord equals the angle that subtends that same chord in the alternate segment there, or in the alternate, right in the top of that triangle, that angle E equals B1, the tan chord theorem. Well, if we can match up two angles, then in a triangle, because of angles in a triangle, all three angles must match up. So then we can say triangle CDB is similar to triangle CBE because of angle, angle, angle. And there's the first three questions, all done. The first three questions, all done. So we'll leave it there.